Okay, hello. So today we're looking at question 2, add two numbers. You're given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order and each of the nodes contains a single digit. Add the two numbers and return the sum as a linked list. You may assume that the two numbers do not contain any leading zero, except the number 0 itself. So we are given the digits in reverse order, and that will help us simplify things a little. So let's look at some examples given. Example 1, we can see that 2 plus 5 is 7. So we, for the output list, the first node, we append 7 to it. And then 6 plus 4, we get 10. But then we carry over 1. Note that we're doing the addition in a reverse order, so I am writing the carry like that. So 4, 3, 1 added together, we get 8. Yeah, so this is our output linked list, basically. Okay, so looking at example 2, we're given two linked lists that only has one node in it of value 0, because the constraints in the constraints they told us that linked lists are not empty. It contains at least one element and can have a max of 100 nodes. And so example 2, with 0 plus 0, we output 0 as our final linked list. Example 3 is more interesting because it shows us how linked lists 1 and 2 does not have to be of equal length. So we kind of have to be aware of that. So it's also basically the same thing. 9, 9, 9, 9, 9, 9. So I'm doing this addition in a reverse way. So my carry, I'll write it to the right instead of the left. 9 plus 9, we get 18, right? Yeah. So 18, 9 plus 9 plus 1, 19, 10, and finally 0, 1. Okay, so now that we've gone through the question, let us let's start thinking of the implementation. Right, so we obviously need to basically figure out what values, what nodes to add to the linked list, right, as we traverse through linked list 1 and linked list 2. So I'm thinking of just writing a append function where we can use it to basically append a certain value and make it like a node, and then we append it to a linked list, our output linked list. So how the append function works will be how it works is that we'll take a value and then append it at the end of a linked list that we pass in as a parameter. So def, let's call it append node, just one, each time we call this function. So we'll give it a my linked list, and then the value we want to use as the new node that we want to append to this my linked list. Okay, so first thing is to create the new node, right? It'll be of list node def structure, so my val, and then we have to traverse through the my linked list to figure out where to append this new node. So while my linked list dot next, we kind of move down the list, like list equals, and then we do at the end of it, so now that we are on the last node, we do my linked list dot next, we assign it to this new node, and then we return. Okay, so now that we have our append node function done, let's think of how we want to implement this add two numbers function. So what we want to do is basically traverse through L1 and L2, right? But we have to be mindful that they might not be of the same length. So our while loop will have to continue until like both of the lists like run out, like finishes traversal. Yeah, so it will be, but before that, let us initialize the output linked list, right? Let's call it output list. Maybe we'll just give it a dummy value of 0, so we just initialize it and don't have to pass in anything, because the definition that they gave us here, they wrote that, if you don't pass anything, you'll just take the value 0 as the first node. Okay, so output list, and now we can write our before that, we have to initialize a carry, because at the beginning we basically our carry is 0, right? Like, okay, so while L1 or L2, because like if one of them ends, kind of we still want to continue, or carry, because if you remember the example 3, we have like one carry left over after both L1 and L2 finishes. So we'll write that. Okay. Yeah. If L1, then we want to basically like extract the value of L1, so, and like do stuff with it, right? Else L1 val, we'll just give it a 0, so we don't risk like adding a none to an integer value in case like L1 is shorter and L2 is longer. But like, let's maybe write this, we can write this in a more Pythonian way. So we can do like L1 val equals this, if L1, else 0. Yeah, same for L2. Val if L2, else 0. Okay, so we have that. Now what we want to do is, now that we have the values, right, basically figure out what value it is that we want to use to pass into our append node function that we just declared like above. So sum to add equals L1 val plus L2 val plus carry. So, but like, we don't necessarily want, we can't really pass in this sum to add yet, because like what if sum to add is a double digit number? Then we don't want to append that yet, right? So what we can do is to kind of like, wait, maybe we should call it differently. We can call it sum to append. Next is like the one that we actually want to use. So sum, how we would get that value is by manipulating sum to add a little bit, right? So let's say if we wanna if the sum to add is 11, we basically just want to add, okay, let's give another example, maybe like 12. We basically want to add just 2, right? And then the carry is 1. So to obtain these numbers, what we can do is, like, sum to append, we do a remainder. So we can do this, and that will give us 2. And then to get the carry, we use sum to add, and we do this, and we get 1. So now we effectively have our sum to append and carry. Yeah. Okay. Exit drawing mode. Okay, so sum to append, we do carry is now sum to add. Okay, now that we have our sum to append, we just call that append node function output list, and sum to append. Okay, now that that's done, we can just basically keep like traversing through the L1 and L1 and L2 linked lists, right? So L1 equals L1 dot next if L1 else none. L2 is remove dot next if L2 else none, and finally we return output list dot next. Okay, let's see if it works. Okay. Okay, great. So that's it for today's video. Thank you for watching. See you soon.